Hey YouTube, welcome to episode 2 of Straight Line Graphs. Today we're going to look at perpendicular lines, so let's get right into it. So, what we should have learned from GCSE is that when we have gradients, we can easily find the perpendicular gradient by doing the negative reciprocal. So, if we have a gradient of 2, that's 2 over 1. So when we reciprocate that, we get a half, but we have the negative reciprocal, so we change the sign. Minus 3, 3 over 1 becomes 1 over 3. But changing the sign, a minus then becomes plus. 1/4 will become 4 over 1, which is just 4. Then you make it negative. Then here the negative will disappear, and we flip the fraction 7 over 2. So, in general, they do ask for this rule sometimes, is when two gradients m1 and m2 are perpendicular, then if we multiply them together, what do we get? Well, because we have the reciprocals of each other, if you take a number and multiply it by its reciprocal, you always get 1. But because you always have a change in sign, they always multiply to minus 1. So that's a rule we need to remember, and it's very useful when we come to do algebraic gradients. So let's take a look at this question. It says the line with equation x minus 3y plus 4 is 0 is perpendicular to the line with equation 2x plus ky minus 2 equals 0. Find the value of the constant k. So for them to say it's perpendicular, we're focusing on the gradients. So for both lines, we need to work out what the gradients are. So for the first one, we need to move the 3y to the other side. We'd get x plus 4 equals 3y. Then we divide through by 3. So y would be 1/3 x plus 4/3. So the gradient here, I'm going to say m1 is 1/3. For the second equation, I'm going to keep the ky here. I'm going to move the 2x and the minus 2 to the other side. Then we divide through by k. We'd get y equals minus 2 over k x plus 2 over k. So the gradient here, m2, is minus 2 over k. So all we need to do is multiply them together and equate it to minus 1. Yeah, so we're going to say 1/3 times minus 2 over k is minus 1. Multiplying the top and the bottom, we have minus 2 over 3k is minus 1. Times through by the denominator, we get minus 2 equals minus 3k. The minuses cancel, and we're left with k equals 2/3. This is applied to some exam style questions. So a straight line L1 has equation y equals minus 3x plus 2. The straight line L2 is perpendicular to L1 and passes through the point with coordinates 3, 4. Find an equation of the line L2 in the form ax plus by plus c is 0. So from the line L1, we can say that the gradient is minus 3. You could call it m1. So the perpendicular gradient m2 will be the negative reciprocal of that. That will be 1/3. Then for the previous episode, we proved what the general equation of a straight line, we're going to use that. So it's y minus y1. Now it does say here that it passes through 3, 4, which we're going to make those substitutions. So y1 here is 4. So y minus 4 equals 1/3, the gradient, x minus x1, which is 3 in this case. Now remember, when we deal with fractional gradients, we always times through by the denominator. So here we have 3y minus 12 equals, the 3's cancel. We're just left with 1 lots of x minus 3, which is just x minus 3. Then move everything to one side. You can move it to the left or the right, it's up to you. The line L2 crosses the x-axis at the point A and the y-axis at the point B. Find the coordinates of A and B. So what we know is that when any graph crosses the x-axis, the y value is 0. So when we sub in y is 0 here, we'd be left with minus x minus 9 equals 0. Move the minus x over, x equals minus 9, because the minus x is going over. So the coordinate, it says it's the point A, is minus 9, 0. Then it meets the y-axis at B. So where does anything meet the y-axis? You make x equals 0. Now when x is 0 here, we're left with 3y minus 9 equals 0. Move the 9 over and divide by 3. So y is 3. So the coordinate of B then is 0, 3. Finally, it says, given that O is the origin, find the area of the triangle OAB. So for a situation like this, I always recommend you do a sketch. For any kind of coordinate geometry, it's always useful. So the line, this is also a really easy way of sketching lines. You just work out where it crosses the x and y axis. So we have -9, 0, and we have 0, 3. So there. So the line looks something like this. So the A is this point, B is this point, and we have O, they're asking for this area. So we have the base length here is 9, and with the height is 3. And it's a right angled triangle. So we're going to do the area is a half times the base length 9 times the height of 3. 9 times 3, 27. So we're just going to say 27 over 2. Now you can leave it like that, or they haven't given us any units, so you could say units squared. Hey guys, I hope you're enjoying the video. If you're new here and you want more maths content, then please consider subscribing. If you're learning something, then hit that like button and comment down below to let me know what you want to learn next. I hope you enjoy the rest of the video. Okay, so let's take a look at an exam question. It's a slightly more difficult question. It's got nothing to do with perpendicular lines, but just lines in general. Next episode, we're going to look at some more coordinate geometry, distances between points, and apply it to some more exam questions. So what does this one say? It says the line L with equation 2x plus y minus 8 is 0, intersects the line M with equation x plus 3y minus 9 equals 0 at the point P as shown in the diagram. Find the coordinates of the point P. So what we discussed in the last lesson is that whenever you see the word intersect, you're thinking about simultaneous equations. So in our case, I'm just going to rearrange for y. It would be y equals minus 2x plus 8. The other equation can just stay as it is. So I'm going to sub in y into there. So we're going to get x plus 3 lots of minus 2x plus 8 minus 9 equals 0. So we have x minus 6x plus 24 minus 9 equals 0. So we get minus 5x. 24 minus 9, 15 is 0. And when you rearrange that, you're going to get x equals 3. Then we sub it back in for y. We'd get y equals minus 2 lots of 3 plus 8. That's minus 6 plus 8 is 2. So our coordinate for P is 3, 2. And in the exam, I always recommend you just add that to the diagram. It then says the region A1 is bounded by L, M, and the y-axis. So it's just saying there's 3 boundaries around A1. You have L on the top, you have M on the bottom, and you have the y-axis. A2 is bounded by these 3 lines. Show that the ratio of the area of A1 to the area of A2 is 3 to 2. Now we can see A1 and A2, they're triangles. Now all we need to do is we need to go back to how we first learned about triangles probably as 11-year-olds. Not all triangles, obviously, are right-angled. Obviously, that would be nice. But the question is, how do you work out the areas of triangles that are a bit of an awkward shape? Now, it's really easy. It's the same formula. You take the base length and you take its perpendicular height. You would have learned it as perpendicular height. You may have just forgotten it. And now you're conditioned to just say half base times height. Now, what is the perpendicular height? It's from the top of the triangle vertically downwards. Then you just do half base times height. Now, if you look at A2, for example, you have that same style. You have the base length, which we'd have to work out, and you have its vertical height. Now, the vertical height you actually know. It's the y value of P, it's 2. So we just need to work out where the lines cross the x-axis, and we can work out the base length. How do we work that out? Well, we know to work out where lines cross the x-axis, we make y equals 0 for both. Look at the first equation. If you make y equals 0, you get 2x minus 8 is 0. So x equals 4. And that's for the line L, so we can add that in. That's 4 there. Then for the other equation, if you make y equals 0, you get x minus 9 equals 0. So I put 4 in the wrong place. L is actually here. So you get x equals 9. And that's where this should have been. So the base length then is 5, right? That base length there is 5. So what's the area? The area is a half times the base length of 5 times the height of 2. Half cancels the 2, we're left with 5. And you could say units squared if you want. I'm going to change color. Let's talk about A1. Now A1 is basically the same as A2, it's just rotated 90 degrees. In terms of how you should visualize working out its area, is the base length is actually this vertical here, and its height is from P directly to A1. If you tilt your head sideways, you can kind of see where I'm getting at here, which means that the height is actually the x value, it's 3. We just need to work out where does it cross the y-axis, which means we make x equal 0. So now when we make x equal 0, for the first equation, it will just say y minus 8 is 0, so y is 8. And then for the other one, when you make y equals 0, you get, when you make x equals 0, you get 3y minus 9 is 0, so you get y equals 3. So just putting those in, we have 8 and 3, which means this length here is 5. So what's the area then? The area is a half times the base length, which is 5, times the height of 3. So that gives us 15/2. Okay, so the last thing we need to do then is we need to write down the ratios. So the first one I did actually was A2, right? And this is A1. So the ratio of A1 to A2 is 15/2 to 5 times by 2 on both sides. So we're going to get 15 to 10, then divide both sides by 5. We get the ratio of 3 to 2. And that's now shown. So what looked like a more difficult question, when you just remember the basic rules from when you were 11 years old, remember the definitions, we say perpendicular height for triangles, it actually turns out to be not that bad of a problem. So that's it, guys. We did perpendicular lines. We looked at a more tough exam question that they can ask you in year 12. So stay tuned for the next episode. We're going to do some more coordinate geometry and do some more tough questions on straight lines. So if you learned something new, guys, please hit the like button, subscribe if you want more maths content, and I'll see you all in the next episode. Peace.